Hi guys, so we're going to continue with elimination, and I'm going to show you how to work some problems that are a little bit different from the other ones, but actually not all that different. The idea is still going to be the same, that you want to add the two equations and have one of the variables drop out. The only difference here, so if you look at example 1, neither variable, if I just were to add them as is, neither variable is going to drop out. And I can't multiply either equation by -1 and have a variable drop out. But I'm going to look for the one that, like for example, on the y's, if I were to multiply the top equation by a 2, I would get a -10y here, and then I would have a +10y here. Then I could add the two equations. So I'm going to multiply top equation by 2. So it's kind of the same idea really as if it were -1. So you multiply every term by 2, and I get 8x minus 10y equals 46. 3x plus 10y equals 31. This is 11x. These cancel out, and that's going to be a 77. All right, so finish solving for x. X is going to be 7. And then plug the 7 into either of these two equations. And it doesn't really matter. I'll use the first one. 4 times 7 minus 5y equals 23. So 28 minus 5y equals 23. Now I'm going to move the 28 to the other side. -5y equals, that's going to be 23 minus 28, -5y. So anyway, y is going to be 1. And my answer is 7, 1. If for some reason, as you're solving, say you were solving this first equation and you would get like, I don't know, 77 equals 77 or something like that. Just like in substitution, if you get the same thing on both sides of the equal sign, the same number or the same variable, that would be an infinite solutions. And if I were to get like, I don't know, 1 equals 77, that would mean no solution. All right, example 2. Let's try this. I'm going to do this one 2 different ways. So x minus 5y equals 2. 2x plus y equals 4. Now looking at this one, nothing is set up for me to just add straight off the bat. But there's a couple things I could do. I could multiply the top equation by a -2, in which case the x's would drop out. I could also multiply the bottom equation by a +5. That would be another strategy to solve it. Either way would work, so I'm going to show you both. Starting off with, I'm going to try to get rid of the x term first. So let's just call this let's see, method 1. It's not really a method, but multiplying the top by -2, I get -2x plus 10y equals -4, and then 2x plus y equals 4. All right, so adding x's cancel out, that's 11y equals 0, dividing by 11. Now this doesn't mean no solution. I can solve this and I get y equals 0. It's okay to have a 0 in the numerator. And then plugging that in to the, say, first equation, x minus 5 times, this is really easy to solve, but you get x equals 2. So the answer is 2, 0. Now let's say instead of getting rid of the x terms, I choose to get rid of the y terms. So I'm going to do that same problem. X minus 5y equals 2. 2x plus y equals 4. This time I'm going to multiply the second one by a positive 5, because my goal is to get the y to drop out. So method 1, let me write get x to drop out. Or method 2. The point is, sometimes you have a choice on a way to go. Get y to drop out. All right, so in this case, I have the same top equation, and the bottom one becomes 10x plus 5y equals 20. And when I add, remember I am adding in all these, 11x equals 22, 22, excuse me. So x equals 2, plugging back in, 2 minus 5y equals 2. Well, if I throw this 2 over, I'm going to get 2 minus 2, so negative 5y equals 0. Dividing by negative 5 is going to be 0. So there, I get the same answer. So it doesn't matter which way you do it is the point of that. Okay, one more. And let's see here. 3a plus 4b equals 2. 5a plus 9b equals 1. Now, on this guy, there's nothing obvious that jumps out at me. Like, I can't multiply 3 by anything and have it make a negative 5. And I can't multiply 4 by anything and have it be a negative 9 easily. So the idea is to get these two, let's say we're going to do the a, to get the two a terms to be the same but opposites. So I'm going to multiply the top one by, let's say, 5. If I do that, I'm going to make a term 15. Let's multiply the bottom equation by a negative 3. That'll make the bottom a term a negative 15. And 15 plus negative 15 will make the a's cancel out. I could do a similar thing with the b's. I could multiply, let's see, what's the least common? You want to find the least common multiple. Is it 36? I guess it is. I could multiply the top by a negative 9 and the bottom by a positive 4 or something. Anyway, top equation, 15a plus 20b equals 10. Negative 3 times 5 is negative 15a plus negative 27b equals negative 3. You just have to be careful to multiply every term in the equation by this number. And watch the signs too. So see, now if I add vertically, these two guys are going to go to 0. 20 plus negative 27 is negative 7b. And then 10 plus negative 3 is 7. Divide by negative 7. And b equals negative 1. All right, I'm plugging back in. Let's see, I'm going to go back to this one. 3a plus 4 times negative 1 is 2. I always like to use the first equation. I don't know why, for no good reason. Okay, move the negative 4 over. 3a equals 2 plus 4. 3a equals 6, of course a is 2. All right, so that gives me 2, -1, A and B. And like I said, if you were to solve this equation here, this first equation, and you get something like 7 equals 7, you would say infinite solutions. Or if you got 3 equals 7, you would say no solution. And of course, you can also check your answer. And that's it.